Hi students, welcome to chemistry online classes. Now I want to discuss about the macroscopic or that is called bulk properties. The macroscopic or bulk properties are pressure, volume, temperature, number of moles, etc. These are called macroscopic properties. Another one is thermodynamic properties. Thermodynamic properties mean the property which define the system. The properties which defines the system are called thermodynamic properties. So these are also called thermodynamic properties. Now these thermodynamic properties are two types. One is extensive properties another is intensive properties. So these are very important for competitive exam purpose and also the board exam purpose. Extensive property means the properties whose value depends on quantity or size of the matter present in the system. So I will write the definition. The property whose value depends on quantity or size of matter present in a system, that is called extensive property. Extensive property means it depends. Same definition here. The property, sorry, forgot to write, whose value depends on. Here, do not depends on quantity or size. So I don't want it the total. I want to change here. The property whose value do not depend. So whose value you can write extra here. Do not depend on the quantity or size of matter present in the system. Simply it is called independent of the quantity or size. So you write the definition. Definition is very important for board exam level, but competitive exam level you have to remember whose value do not depend. So that is intensive. Independent, this is the property whose value independent of quantity. So I want to write here I is there, then you have to write independent of quantity or size. So I is there, then here also I, then remembering purpose, independent means intensive, depend means that is extensive property. Okay, very important. Now examples. Now what are the examples are there for this? Volume or mass. Now this is the pen. If you add this, mass what happened? Increases. So mass is extensive property, quantity or size. Before this, size this much. When you add one extra, size what happened? Increase. Then mass also increases. Mass, volume. Now you take the 1 liter water bottle and in that add half liter water. If you add extra half liter, then what happened? Volume increase. So volume is which one? Extensive property. Mass, volume, number of moles or number of molecules heat capacity, another is internal energy, generally denoted with U, enthalpy denoted with the H, Gibbs energy denoted with the G, entropy denoted with the S, etc. These are, another one is resistance also. Resistance, these are, which one? Extensive property. Resistance also depends on the size. So some example I given, some other also may be present. So competitive exam purpose, we have to, not only in chemistry, in physics also some properties are there that you have to include here. So because general resistance word you are more using in physics, so like this property also may be their extensive, intensive property based on their dependence, independence. Okay. So second here, intensive property, which is do not depend on its quantity or size. The best example is density. Water density, 1 drop water density also 1 gram per milliliter. If 1 liter also 1 gram per milliliter only. So density is do not depend on its size or quantity. Next, pressure. Another is temperature. Now I am present in the one room. This room pressure is 1 atmosphere. Another room also 1 atmosphere. If you remove the middle wall of the room, then 1 plus 1 is 2 atmosphere? No. Totally this is 1 atmosphere. Negligible change may also, but that is considered one room. And if you consider temperature, this room temperature is for example 26 degrees Celsius, another room also 26 degrees Celsius. If you add 26, it may be, what do you call, nearly 52? No, it is nearly same 26 only. So temperature do not depend on the size. So one room size is, for example, you consider in when you are sitting in your house, that room size consider, another room also in the same size. If you add the two rooms, there is no change in the temperature, there is no change in the pressure, but volume will be changed. If you add 2 rooms, then volume what happened? Increase. If otherwise, if you sit in a one room and make into one wall extra, then it is half. Then V by 2, but temperature pressure are nearly same. That is, these are intensive properties. Another one is pH, EMF or cell potential. These words will come in the physics also, chemistry also. This is come in the generally in chemistry. Mainly we are using for electrochemical cells. Next, specific heat capacity. Now here heat capacity is there. Here what is there? Specific heat capacity. Here mass is there. Here what is there? Molar mass or molar volume. For any extensive property, if you add molar or specific, then it becomes intensive property. Otherwise, ratio of two extensive property, that becomes which one? Intensive property. Because density formula what is there? Mass by volume. Mass also extensive property, volume also extensive property. The ratio of these two will become intensive property. Because if you take, this is the one test tube, in this water is there. Yeah, how much? 2 ml water is there. Another 2 ml added in. So volume is 4 ml. Mass also what happened? Increase. So same ratio, mass and volume increase. Therefore density remain same. Therefore extensive property ratio becomes intensive property. For any extensive property, if you add specific word or molar word, it becomes intensive property. So now molar volume. Okay. Here resistance is there. Here resistivity. Resistivity. This is which one? Intensive. If you write here conductance, here conductivity. So these are very important for competitive exam. You have to remember this all. So I given some examples. some example you have to remember. This is an extensive and intensive property. It depend, it independent. These are some examples. Very. So this is simply called our additive property. Additive means now these two are add, then it is depend. So these are additive property. These are non-additive property. If you add also, there is no change in their value. Therefore, these are non-additive property. These are additive properties. Now, the state of the system. A system in a given state when all thermodynamic properties are fixed. For example, this is one system. That is called ice cube. What do you call this? Ice cube. This system will be in a given state. Given state means what is that ice cube? It is solid state. When it will be in the solid state, all thermodynamic properties should be fixed. That is called pressure, volume, temperature, like this, etc. should be fixed. When these are not fixed, then it will be changed from one state to another state. For example, temperature increases, then this ice cube will be converted into liquid. When you increase the temperature, this will be converted into liquid. Therefore, here the state of a system will be in a given state when all thermodynamic properties should be fixed. Now, to define a system or a thermodynamic system, the macroscopic properties or bulk properties or measurable properties. Now only we discuss what are the bulk properties or macroscopic properties. So to define the state of a system, what are required here? Measurable properties, measurable or macroscopic, or it is also known as bulk properties are required. What are the macroscopic property or bulk properties or measurable properties? Pressure, volume, temperature, number of mole, etc. These are which one? Macroscopic property or measurable property. These are also known as state variables or state function. Also known as a state variable or state function. To define a system, the state of a system. To define a state as state of a system, all properties are not necessary to define. Some properties are variable in their value independently. Therefore, the number of properties, it means the number is depend on the nature. So, how many properties are required to define? That number is depends on the nature of the system. So, you read your textbook, then you will know the clear. So, now what I am telling here, for example, this is a system. To define the state of a system, all properties are not necessary to define. Few properties are enough. The remaining properties are automatically, they fix their values. They are having their certain values. So not all need here, only few properties are required. That is state variable or state function. Mean why these are called the state variable or state function? To define the state of a system, these are required. Therefore, these are called state variable or state function. Keep in mind, to define a state of a system, all properties are not necessary. Only few are required. Few automatically fix their values. Therefore, we can define the state of a system. After this, state of a system, Now we use one word here, state function. Another is word also is there, that is path function. First I want to define here state function. Very important for board level. State function means the properties which depend on initial and final state of the system. The property which is depend on initial and final state of the system. They are called state function or state variables. It is independent of how the system changed or carried out from one state to another state. It do not depend how it is carried out. It depends on initial and final state. Example, pressure, volume, mass, and temperature, internal energy, enthalpy. U mean internal energy, H mean enthalpy. Again, we will discuss next after this. And entropy, Gibbs energy. These are the some examples of state function. Now another one is that is called path function. Path function. Path function meaning what is that? It depends on its path when a system changes from one state to another state. See here the property which is depends on initial and final state of the system. It is independent of how it is carried out. Now the property which is depends on path. How it path mean what is the how it is convert path when it change from one state to another state. So that property is called path function. Only two examples are there for this. One is Q, another is W. Q mean heat, W mean work. Once again I am telling here this heat and work are neither extensive property nor intensive property. Very, very important these are. These are only boundary phenomenon but not extensive, not intensive. These are only here path function. Here these are all state function. For example, how to understand these are the state function and how to understand these are the path function. Okay, I will give some